Welcome to the InfoWerx Cisco Academy Learning Podcast Series. These videos are provided by John Owens and Chris Hand, Cisco Academy instructors at GST BOCES Pauline Bush campus. This is Series 1, Network Mathematics. This series starts with understanding numbering systems. This is the second video in the series, Introduction to Binary Conversion. Now before we can start this lesson, let's review some of the numbering system names. Today we will be discussing binary or base 2. In the previous video, we reviewed the decimal or base 10 numbering system. Please remember that if any time this video is moving too fast or you need to process, pause the video for reflection and review. Binary is the numbering system of the digital circuit. At its simplest, it is solely a way to represent the states of on and off, 1 being on and 0 being off. There are only two numbers that can be in any position. These numbers are 1 and 0. We refer to the single binary digit as a bit. 8 bits is referred to as a byte. Here is a simple binary number, 101. You can see I put the decimal value of the number below, which is 5. You may remember we reviewed the position values of a decimal number in the previous video. All numbering systems have place values, and binary is no different. Let's take a look at what makes up a binary number using the value 101. As you can see, I noted the 1's position. This will be the same for every numbering system you learn in the series. The next position's value is the 2's position, and the last position is the 4's. Now the reason these positions have the values of 1, 2, and 4 is due to the fact that each position is a power of 2. Let's take a look. Here is the positions with their place values again. And now let's add some more information. First, the 1's position can be represented as 2 to the 0 power. Note that any number raised to the 0 power is 1. Also note that the base, in this case 2, is the number we use to represent the value positions. Now, let's take a look at the next two place values. The 2's position can be represented as 2 to the first power. You should note that any number raised to the first power is itself. And lastly, let's look at the 4's position. You have probably figured out by now that this position can be represented as 2 squared, or 2 to the second power. Another way to determine position value is that you can figure out a position's value by multiplying the base to the position to the right. Let's look at an example. In this case, we are still dealing with the number 101. The trick in this method is to remember that all numbering systems that we deal with in this class start with 1 as the least significant digit. So the first position is always 1. Now in order to find the next position, we multiply the first position, in this case 1, by the base value, in this case 2, giving us a position value of 2. In this example, obtaining the value of the last position is accomplished by multiplying 2, the value of the second position, by 2, giving us the value of 4. Now that we understand the idea of position values, let's look at them in a different fashion. In this image, the base 2 position values have been placed into a table, and we have added the 8's position, or 2 cubed. When you are dealing with numbering systems that are foreign to you, this is the best way to write out their position values for easy conversion. Now let's place a base 2 number beneath the place values, and in this case it's going to be 1101. If we multiply the position values by the number in the positions, we get the following values, 8, 4, 0, and 1. This is shown on the image and will be referred to as multiply down from now on. To obtain the value of the number, we then add all the position values together and obtain the value 13. This will be referred to as adding across from now on. Since this may be your first exposure to binary, I felt a little practice may be in order. In the next few examples, pause the video if you need some time to follow along. Let's convert the following binary number to its decimal equivalent. The number in the example is 1010. First, place the number in the table that contains the position values. Once it is in the table, multiply down, then add across. Pause now if you need some time to do this on your own. Once you've multiplied down and added across, you will get a value of 10. Look at the example. Let's try another one. Convert the number 1111 to its decimal equivalent. First, enter the number into a binary position table. Then, multiply down and add across, and you will get a value of 15. In the next lesson, we will expand to 8-bit numbers, which will help when we start our discussion of IP version 4 addresses. Thank you for taking the time to watch the InfoWerx Learning Podcast series, and we hope you enjoyed the lesson. We'll see you next time.